Today, I will be presenting exponential functions, and my name is Nicholas Matus, and I'm currently taking the class of Intermediate Algebra, which is MAT 115 BE. Overall, exponential functions could absolutely relate to real life scenarios and can even relate in a biblical perception, which we'll dive into deeper, as we also will dive into the historical past and how it came along and who even created it. So let's dive into it. What are exponential functions? The definition of an exponential function is an equation that can be easily recognized as an equation with the variable in the exponent position. Basically meaning that if I were to give an example, which I will in the next few slides, that I'll give the example of ab to the power of x, that x would be known as the exponent, or even called the base. The exponential equations can have any positive integer as the base number except for 1. And an exponential function is the x value itself. As the x value increases, the y value becomes greater and greater, which is absolutely true and also relates to how it can be associated with real life scenarios, but we'll get into that later on. This is why the graphs you'll see increase at such a high rate, because no matter how high the x value goes, the y greater will be greater. The y value would be greater than the x value. And an exponential function can never be 0. So no matter how negative we go into the numbers, it'll always be 1 over or any other number except for 0. So it doesn't matter how negative we go, it'll always end up being 1. Here's an example of a generic function. As you could see, y equals ab to the power of x. And so if we were to put a is greater than 0 and b is greater than 1, then the slope to the right you'd see is going to curve at an angle from the left x-axis towards up, right, y-axis, which is a good example because it shows that the y-axis would be greater if this scenario were to happen. Another example is if a was greater than 0, but 0 was less than b and b was less than 1. You'll see it'll go from the right side of the x-axis up to the left of the y-axis. And here's another example of still same, but just different scenario of a being less than 0 and b being greater than 1. You'll see the curve now instead goes to the left of the x-axis towards down of the y-axis. And finally, our last example is if y equals abx, ab the power of x, a is less than 0, but 0 is less than b and b is less than 1, then you'll see that the curve goes from the left side of that the right side of the x-axis onto the left bottom of the y-axis. And as you see, there's a common pattern that these functions do not curve into 0, or they do not touch 0. And now we'll dive into how exponential functions were created. John Napier, the person on top left, discovered it when he introduced logarithms to simplify calculations, and Leonhard Euler formalized exponential functions and introduced e to the power of x as a fundamental function. I found this information through a source of a background letter, or even a really old newspaper, of how this idea came along and how it shifted into a really big growth during the early ages. and it really shows the history of how exponential and logarithmic concepts arrived. How can exponential functions relate to us? Overall, these concepts are the ones that I thought of the most, which is finance, which is a huge part of our lives as we grow as adults. We'll always have to make investments and loans, and even as a college student, you always have something that is going to increase. Like if you were to make a savings account, that you put more money in, the more your interest will grow, which is really close to exponential function as it keeps increasing. We have another one as biology. As a biology student myself, I recognize this because population is really high on growth right now. And even learning about bacterial and fungi growth, it'll always be increasing no matter what, because how bacteria and archaea reflect on us and create more organisms to grow in, things like that. Another one was physics. A big concept of physics I picked up on that relates to this is the decay of electrical charge, which is similar to one of the examples I showed, that how it goes from curving at the top to going down, sloping down towards the bottom of the y-axis. Another one is computer science, which is the growth of algorithms, how our day-to-day life will always be affected by technology, and it's always increasing and going skyrocketing up towards new advancements. A biblical representation is Genesis, be fruitful be fruitful and multiply, which I picked up on as a great ideal concept to connect to exponential functions, as it shows great sign that God wanted us to grow and create this motion towards going up and spreading his love as brothers and sisters. Another one I got was from Job, which is God is great beyond our understanding. And this is great because at first, even myself, this concept was pretty difficult to pick up on. And it's like how God doesn't really give us his right answer of what he wants us to do until we really go out there and find it and practice it and spread it how we want to be able to master his love in order to figure out our potential and grow in it. Which is why, as I was learning this concept, you really have to figure out how to utilize this to be able to understand it and even do well in it. Another one I found out was from Matthew. Faith as small as a mustard seed, growing exponentially. The mustard seed story is really great as another form of population growth. I thought it was just really beautiful because I knew this tale as a child, and it really caught my attention when I was looking for quotes to talk about, and this source really helped me connect to exponential functions, which is great because exponential functions will always be increasing or decreasing, but in all these three representations, these are all increasing factors. And that is my presentation. Thank you all so much. And here's my sources cited page. We have the sub-exponential growth of early Christianity, exponential functions, applications of exponential functions in our real lives, and a history of the exponential and logarithmic concepts, the American Mathematical Monthly. Thank you all so much. Have a blessed day.